Now we're going to talk about ellipses. So ellipses are sort of like circles that have been squashed, either short and fat, or if I squeeze it this way, it's going to look tall and skinny. So much so that the equation for these actually start off looking very similar to circles. So I'm going to start off with x minus something squared plus y minus something squared, except this time it's going to equal 1, okay? And the other difference is you're going to have a denominator. Now, here are the similarities. H and K is still going to be the center of your ellipse, just like it was for the circle. So there's my center. Same thing for this setup right here. It's going to be x minus something plus y minus something equals 1. Again, these are going to be fractions. That's really the difference. HK is still going to be the center. Here is the center right there, okay? Now, the difference between a short and fat versus a tall and skinny are these denominators. Now, the way I like to look at it is, this is sort of like the main or the major axis. It's like x. So if the major axis is like x, then a, the larger number, goes underneath the x fraction. If the major axis is up and down for a tall and skinny one, then it looks like the y-axis is the main or major axis. So I put a underneath the y. So the smaller number, b, is going to go under the y in this situation, and it's going to go under x in this situation. What the heck is a and b? A is the distance from the center to what I call the major vertices. Okay, so it's the distance from the center to the point all the way at the edge. So I'll call this capital M, V for major vertices. Same thing here, capital MV. If it's up and down, then this will be your major vertex, and this will be another major vertex. B is the distance from the center to what I call the minor vertex. I think the book uses co-vertices, okay? I'm just going to call this the minor vertex, so lowercase mv. In this situation, the minor vertices are left and right of the center. And then finally, there's one more letter that we haven't talked about, C. C is the distance from the center to the foci. Foci is just plural for focus. Okay, so here's the foci. It's these invisible points that are inside your ellipses. So for up and down, tall and skinny, it looks like that. What is the relationship between A, B, and C? This is what I call the anti-Pythagorean theorem, which is a squared minus b squared equals c squared. So if you know how to set up your formula, if you know all these little components, A, B, and C, just know what they are, what they mean, and the relationship between those, then solving these shouldn't be too bad.